This is the synthesis of benzanilide. This is another type of amide. The first type of simple amide we have discussed earlier, which was the synthesis of benzamide. This is the other type of amide, which is N substituted amide. You can see simple amides are like this, in which nitrogen has no substitution except hydrogen, and N substituted amides are mono substituted, in which nitrogen is substituted with one R group, and disubstituted amide are substituted with two R group, and there is no free hydrogen. This type of amide, which is benzanilide, is a type of mono substituted amide. So as you know, all amides are prepared by the acyl group, means acidic moiety and amino moiety. Here the acidic moiety is same as that of benzamide, in which there is a acid chloride of benzoic acid, and the amino moiety is different. In that case you just use ammonia in water. Here we are using aniline, means the substitution of amide is benzene ring or phenyl ring here. So the respective amide should be used as aryl ring substituted amide, which is aniline. So by the reaction of both of these acyl and amino group, you can get a mono substituted amide, which is benzanilide. When you go for mechanism, it is different from simple amide, means benzamide. Benzamide was prepared by the direct reaction of acid chloride and ammonium hydroxide, as we have discussed earlier. But in the case of mono substituted amide here, which is benzanilide, you are using aniline. Aniline is different from ammonia in reaction due to the presence of this benzene ring. Due to non-availability of this lone pair of lone pairs of electrons are involved in resonance due to the presence of benzene ring, due to which it is less reactive than ammonia. In ammonia there is no substitution and the lone pairs are freely available for the reaction, but here in case of aniline, because the lone pairs are involved in resonance, it is less reactive than ammonia itself. That's why there is a catalyst needed, NaOH, which is a base. Bases are hydrogen acceptors. Here base NaOH can accept one of the hydrogen from the aniline to convert it into aniline anion. This aniline anion can easily react with the benzoyl chloride in the next step, because it is negatively charged. Negatively charged nitrogen is more attracted toward the electrodeficient or positively charged carbon. Here, due to the presence of electronegative atom oxygen and chlorine, this carbon is electrodeficient. So this negatively charged nitrogen can easily attack to this electropositive carbon to get this transition state of the addition product of two molecules, means benzoyl chloride and aniline. This transition state has negative charge on oxygen, which is unstable, so it quickly eliminates chlorine from this transition state to recover the double bond between carbon and oxygen, and you get the final product with the byproduct NaCl. Sodium was free in the first step and chlorine left this molecule, so they both form NaCl, and water was eliminated in the first step also. So the final product along with NaCl and H2O is obtained.